Howdy. Good afternoon, Calc 2 students. This is thought I'd make a quick video on finding area between a curve. So this is the worksheet that I passed out in class today. So I wanted to run through this, and you could work on the worksheet, attempt a problem, then watch the video afterwards to check, see if you made any mistakes and that sort of thing. So here we go. So first thing you always do is do a quick sketch. And if I sketch this thing, x squared minus 4x, let's see, that's going to look that first. So f would look something like this. And of course, g is, we'll just use red. G is that line right there. So that's red. And so if we're looking for the area that's bounded by those two curves, then we're talking about this space here. And again, the next thing I'd want to do is break this up into rectangles so you can kind of see what a rectangle looks like. There's one. There's a little short one over there, etc. So the integral that I'm going to write is going to be height of this rectangle times the width. Now the height, or the width, of course, is dx. The height is going to be this distance right here, this distance right there. Here's another one right there. So it looks like it's always the red line minus the blue line. Well, in this case, the red line is 0 and the blue line is f. So that'd be minus x squared and minus 4x squared, which would be plus 4x. I mean, minus 4x would be plus 4x. And the limits of integration are the zeros. Are the x's. So in other words, this area covers from here to there. And so we want to look at the x values that are involved in this area. So the beginning x value is 0. So I put a 0 right there. This x value right here is where g and f of x intersect. And you could use the graphing calculator to find it. You could just set these equal. You could say, when does x squared minus 4x equal 0, and solve it that way. Of course, if you do that, you get x minus 4 is equal to 0, which means x equals 0, that's that limit, and x equals 4, that's the other limit that I'm looking for, so I put a 4 up there. So then if we simplify this a little bit from 0 to 4, that would be negative x squared plus 4x. Of course, our whole thing is times dx. And now we're ready to integrate or take the antiderivative. So the antiderivative of this would be x cubed. And we need a 1/3 out front because there is no coefficient, and we need a negative. And then we also need a 2x squared. So check to make sure this works. If I take the derivative of 2x squared, I get 2 times 2 is 4, and the power drops to 1 to x, so that works. 3 times 1/3 is 1. 3 times negative 1/3 is negative 1, and the power drops to 2. So it works, and I want to evaluate that from 0 to 4. So I put a 4 in there, 4 to the 3rd power, that'd be 4 times 4 is 16, times 4 is 64. So it'd be negative 64 over 3, plus, put a 4 in there, that would be 4 squared is 16, 2 times 16 is 32. And put a 0 in there, I get 0, put a 0 in there, I get 0, so that'd be minus 0. So I get negative 64 over 3, of course that would be 96 over 3, so that would be 32 over 3. All right, that's the first answer. Okay, moving right along. So we'd want to graph those things to see what they look like. And you could either, if you know that off the top of your head what it looks like, great. If you don't, you can always graph it in your graphing calculator. Okay, so we got negative x squared plus 4x plus 2. And of course, x plus 2 is just a line. You don't need to graph that on your calculator, hopefully. So when we do, you go like this, and you go like this, and it basically looks something like this, with a line going like that, kind of. So once again, we're looking for the area enclosed by these two curves, and we see that it's this little space in here. Draw a couple rectangles, and the integral is going to be the area of those rectangles. So I'm going to integrate from now the height. So this curved line is obviously the parabola. So this is f of x, and that's g of x. So it looks like the curved line is always on top. So we want to put negative x squared plus 4x plus 2 on top. And then we want to subtract from that the bottom line, because again, that's this height right here. This height is that line minus that line. This height is the same thing, that line minus that line. So we're going to subtract x plus 2, so that'd be minus x minus 2 dx. And of course, that would, so then we got to do the limits of integration. So we're going to integrate from here, from that point to that point, because that's where the two boundaries come together. And we'll find that by setting them equal to each other. Again, you can throw this in your graphing calculator and check, or you can do negative x squared plus 4x plus 2 is equal to x plus 2. And you can see it's going to be two places, so you should get two answers up here. So I'm going to move everything to one side and 0 to the other. So that'd be x squared over there, minus 3x, and 0. So that was nice of me. So that would be x times x minus 3. So my two values are x equals 0 and x equals 3. So I go back up here and put a 0 there and a 3 there, because I want to let the x's run from here to there. So that's starting at 0, ending at 3. Okay. So let's combine like terms a little bit here. So that'd be negative x squared. 4x minus x would be plus 3x, and 2 minus 2 would be 0, and then all of that times dx. So when we integrate that, we get negative 1/3 x cubed plus 3/2 x squared. 0, 3. We plug in 3. Let's see. That would be negative 9. Plug in 3 there. That would be 27/2. Plug a 0 in there. I get 0. Plug a 0 in there. I get 0. Okay, so 27 divided by 2. That would be, what would that be? That would be 4.5, or 9/2 is my area. Okay, the next one, this is going to be similar to the last one we just did. So if we graph that baby, it's going to be a parabola with a line across it. So what does that thing look like? So if we graph it, we find out that it is a parabola. And when you initially look on the graph, it looks like it comes down like this, and the line goes like that, and you can't hardly tell if they're crossing or not. So it's probably a good idea to zoom in. And when you zoom in, you see, oh, they do cross. So if we were to look at a bigger blown up version, you see it coming down like this, the parabola, and the line going like that. So there's a little teeny little sliver in there. And it looks like the line is on top, so g of x is on top, and this guy is on the bottom. So when we go to write the integral, we're going to go the integral x plus 1 minus that whole thing, which means I got to subtract each thing, minus x squared minus 2x and minus 1 dx. And I want to integrate from here to here, and it looks like -1 to 0. You could check that if you wanted to. X squared plus 2x plus 1 is equal to x plus 1. I start moving things around, I get x squared plus 1, or plus x equals 0, which means x times x plus 1 equals 0. So sure enough, my two answers are x equals 0 and x equals -1. So I'm integrating from -1 to 0. Let's simplify things again. -1 to 0. Let's see, that would be negative x squared minus x. And that's it. So when we integrate that, we get -1/3 x cubed minus 1/2 x squared. And that's going from -1 to 0. Plug in 0, we get 0 and 0. Plug in -1, but we're subtracting this because, again, what we're doing now is putting 0 into this and then subtracting, putting -1 into that. Okay? So if I put a -1 in there, I get -1 times -1/3, which is positive 1/3. I put a -1 in there, and I get 1 times -1/2, so that'd be minus 1/2. And that's what? 2/6 minus 3/6. Whoa, I did something wrong here. Okay, I see what I did wrong. All this should have had a negative in front of it. So remember what we plugged in 0 here and got 0. Plug 0 in there and got 0. Then you subtract, the next thing you do. Plug a -1 in there and I get 1/3. Plug a -1 in there and I get -1/2. So then I have a -1/3 minus 1/2. So that ends up giving me -1/3 plus 1/2. And that would be 3/6 minus 2/6, which would be 1/6. Okay. Sorry about that little snafu. Okay, so we got one more to do here. So we'll want to graph this thing for sine 4x. And 2x squared. So this one is very interesting, kind of similar to the one we did in class. I think the last one we did, perhaps. Just in the window of my calculator right now so I can see it a little better. So we have something that looks like the y, or the sine curve is doing something like this. And the parabola is doing something like this. So you can see there's kind of three areas there. There's this little area up here, this little area down there, and that area up there. And we got to find all three of them. So notice in the first area, let's make the parabola red. So red. So here's this red curve going like that. And so notice that the first one is blue minus red. So if I'm going to set up that first integral, I'm going to go blue, which is 4 sine 4x minus 2x squared. So that's the first one. And then I'm going to add to that plus the integral. So the next one is red minus blue, isn't it? So that'd be 2x squared minus 4 sine 4x dx. Okay, so then the third section is this one here. And this one has blue on top and red on the bottom. So it's also going to be, these are little addition signs in between here. It's going to be 4 sine 4x minus 2x squared, the dx out there. So there's the four heights and widths. Now we just got to get the limits of integration. And of course we'll find those by figuring out, we have to figure out this point, this point, this point, and that point. Now this point we know because we know this y equals 2x squared and y equals 4 sine 4x both go through 0, 0. So I know that point's 0. X equals 0 there. We just got to find the other ones. And so it's probably easiest to find this by going to the calculator. So remember on the calculator, if you go to second trace, there's a one that says intersection. And I ask you for the first curve, and you say yes by enter. Second curve, yes by enter. And then you move the cursor close to the point you're looking at. So I'm going to do this one over here first. And I find out that it's equal to 0.71, well, 0.720 if I round off to the nearest thousandth. So that's that one. And then I'm going to find this one over here. And so I'll do it again. Second trace, intersect. Yes, that's the first curve. Yes, that's the second curve. Guess. So now I'm going to move it over to the next point of intersection, which is right there. Enter. And it tells me that that one is x equals negative 0.886. And then finally I'll find that one there. So I'll go second trace again, intersect, first curve, second curve, guess, and I'll move up there. And I find out that it's x equals negative 1.312. So then we're going to put those limits of integration. So the first intersection is going to go from negative 1.312. That's the first point, and it'll go down here to that second one, which is negative 0.886. And then the next integral is going to go from negative, get that plus out of there. We're adding all these things up. So negative 0.886. And it's going to go to 0. And then the last interval is going to go from 0 to 0.720. So we're going to integrate that. Alrighty. So if we integrate all those things, I've kind of run out of space here. Let's see if I can fit this down here. So that's going to be the integral of 4 sine 4x. So we know that that comes from cosine 4x, right? Of course, the derivative of cosine of 4x would be negative sine 4, or negative 4 sine 4x. So we want to put a negative out there. But notice the chain rule is going to kick out the right 4. So that'll give me that. And of course the derivative, or the integral of negative 2x squared would be negative 1/3 x, no, I'm sorry, negative 2/3 x cubed. And we're evaluating that from negative 0.886 to negative 1.312. And then we're going to add to that 2/3 x cubed minus, and that's going to be the same idea. This time I won't, actually I don't want a minus because the derivative of cosine would produce a minus sign, right? So we want plus here actually, and that would be cosine 4x again. And we're doing that from negative 0.8. Oops, I did those on the wrong side, didn't I? Whoa. When do you tell me? So I started here at, no, that was right. No, it wasn't. Okay, so this should be, okay, so this should have been negative 1.312, and that should have been negative 0.866. Okay, so that would change that down there too. We want to integrate from left to right, so that'd be negative 1.312 and negative 0.886. So this is negative 0.886, and that would be 0 there. And then last, but certainly not least, we'd integrate that thing, and that's going to look just like the first one. So that would be minus cosine 4x and minus 2/3 x cubed, and I'm evaluating that from 0 to 0.72. So if we plug all this stuff in our calculator, so just not to take up time on the camera time, I went off and plugged all these numbers in kind of off camera. So, and I tried to set it up so you can see that this came from plugging, this came from, maybe I'll use a little highlighter. So this, with that plugged in, gave me this, and this, with that plugged in, gave me this. So that's the yellow. And then the green would be this guy. So the green, I plugged green into that, into the cosine, and got this, and plugged the green into that, and got that. So you can see the second one is coming from plugging the bottom thing in. Whoops, nope, not that one. Let's see, yellow would be here, and here, and here, and here, and then green would be there, and of course 0, because it plugs in there, get 0. So then you add them all those up, and I get 2.557. And this is going a little long, so I'm going to end this video, but hopefully this is helpful. Let me know if you have any questions.